the best way to really learn how to multiply a matrix is to just do an example, right? But I've given you a more simplified, what do you call it, series of steps here. So for the example above here, for this example right here, what is it doing this for? All right, so you have two matrices here, okay? So suppose you are going to multiply for the term C11, okay? You want the term that occupies the position row 1, column 1, right? So you say to yourself, okay, this position is row 1, column 1. So what you do is this. You take row 1 of the first, column 1 of the second, and now what you do is you multiply the first with the first, the second with the second, the last with the last, okay? And you add them. And that's pretty much how it works, okay? So if you want like the term C32,
wait, you add them, you don't multiply them?
You add them. You multiply and then you add. So look, I'm going to do an example. I promise I'm going to do an example. Let's go on to the example. Look at this one, right? First we have to figure out what are the dimensions. So I want to multiply A times B. Okay? Let's find the dimensions of A. A has dimensions 2 rows, 3 columns, so 2 by 3. B has dimensions 3 by 2. Okay? Because the inside numbers are the same, you can multiply them, and your new matrix is going to be a 2 by 2. Okay? So I write down the matrix in the order that I'm given. A times B, A first, then B. So here is A. And here is B. Oh, sorry. All right, now look. My answer is going to be a 2 by 2, right? 1, 2, 1, 2. Is that right? Okay, now, how many numbers am I going to have to find? 4 numbers. Let's start with the first one. Here's the first one, okay? What space does that occupy? Row 1, column 1. Is that right? Okay. So you go to your matrices. It's always row then column. You take row 1 and column 1. Okay? Now, you're going to have to multiply each of the respective terms. Okay? So now, let's multiply the first terms with each other. That's 2 times 2. Oh. So it's negative 2 times 2. Plus, what are the second terms? 0 and negative 1. Multiply 0 times minus 1. I need more room here. Plus, what are the third ones? 3 times 9. So that's the one in the first space. Okay? Now I'm going to go underneath. This is what position? Sorry. All right. Let me erase this. So we had a negative 2 and a 3 here. All right. Let me do this one, the one next to it. Okay? What position is this one here? This one here is row 1, column 2, right? If I could just get my highlighter. This one is row 1, column 2. So what do I take? I take row 1 with column 2. All right? So now I'm going to take the first terms, the second, and the third. So the first ones are negative 2 times 0 plus 0 times 2 plus what times what?
3 times 3.
3 times 3. Okay? All right, next, I want to do the one underneath. Sort of, yeah. You just take like one by one. All right, so next I'm going to do this one. Okay, what position does that occupy? The green one. Row 2, column 1. So I take row 2 with my column 1, and I'm losing some information there, but, so what was this one? This was negative 7. And this is a 2. All right, so I multiply the first terms, 5 times 2. Now the second numbers give me what? Right? And 1 and 9. And finally, the last one here. Yeah, that's row 2, column 2, right? So I take row 2, column 2. Row 2, column 2. So what that gives me is 5 times 0. What else? Negative 7 times 2, 1 times 3. All right, so finally AB is, here we have negative 4 plus 27. How much is that? 23. Next to it we have 0, 0, and then 9. Underneath I have 10 plus 14 plus 9. 10 plus 7 is 17, plus 9, 26. And finally, the last one, it's negative 14 plus 3, negative 11. So that's my A times B. Okay? Yes. Now I want to do B times A, and I'm going to try to like fit it in here. Huh? Sorry. Yeah. Okay, luckily we're doing a screencast, so, all right, so for B times A, what are my dimensions? The B dimensions are 3 by 2, and the A dimensions are 2 by 3. Is that possible? Yeah, and what is the dimension of the new one? 3 by 3. All right, so I write this one first, 2, negative 1, 9, 0, 2, 3. I'm going to do less color coding this time because honestly it's a little inefficient, whatever. Not efficient. Okay. Huh? It's kind of the switching between, I feel like Word is going to just like yell at me now. Okay. So, I have a 3 by 3 here. Right? Okay, so what am I going to get here? This one is row 1, column 1, right? So I take row 1, column 1, okay? And I would do it like this. Row 1, column 1, this is how I do it. That times that, okay? So negative 4, 0. Now, the one next to it is row 1, column 2. Row 1, column 1, right? So 2 times negative 2, 0 times 5, okay? No, it's the first term and then the second, okay? All right, so now let's do the next one. It's row 1, column 2. Here we go. So watch. The first terms give you 0. The next terms give you 0. So that's just 0 plus 0. The last one in this row is row 1, column 3. Okay? So what times what is first? 2 times 3 is 6 plus what times what? 0. Okay? Now, I'm going to go back to the second row. Now this position is row 2, column 1. So I take row 2, column 1. Okay? What are the first numbers going to give me? -1 times -2, so it's 2 plus 10. All right, what's the next position? Row 2. What's that center position? Row 2, column 2. So I get 0 plus 14. Okay. Is it -7? Oh. See, those little, see, it goes away. You see that? Like, I just put in the dash and it went away. So it's 0 minus 14. Okay, look, the last term, okay? This position is row 2, column 3. Is everybody okay with that? Yeah. Row 2, column 3. So I take row 2 along with column 3. Now, here's what I do. Everybody look at me for a minute. With your fingers, if you'd like, just follow the order. The first number here with the first number there, -1 times 3 is 3. The second number with the second number, that's 2. So -3, +2. Okay, the last one. Okay, so Liad, what position is this in? Row 3, column 1. So I take row 3, column 1. Now, what's the first two numbers that I will multiply? 9 and -2 gives me -18. And the second numbers are 3 times 5, +15. All right, next we have row 3, column 2. All right, so Liad, give me these numbers here. Right. Last but not least, row 3, column 3. Hannah, you want to give me those numbers? 9 times 3? 27 and 3. All right? So finally, you just, you add those. So we're going to get -4, 0, 6, 12, -14, -1, -3, -21, and 30. And that is my B times A. Now, what's 3 times 5? What's 5 times 3? Yes, it's commutative. But look at matrices. What's A times B? This. What's B times A? That. Not commutative. So if you have to find A times B, make sure you're multiplying A times B and not the opposite, because they are not commutative. All right? Okay. Okay, so more. These are like cuter ones. So let's find, okay, so for A times B, okay, what are the dimensions of A? 1 by 3, and for B? 3 by 1. So what is my dimension going to be for the new one? 1 by 1. Yes. So, yeah. So AB is -2, 1, 3 times 4, -6, 5, and presumably we're going to get one number. Okay? Now, so we just have one row, one column. So this is the position of this row and of this column. So I just do negative 2 times 4 plus 1 times negative 6 plus 3 times 5. What does that give me?
1.
Is it a 1? I'm trusting you guys. Okay. Now what about b times a? b times a, we get a 3 by 1 and a 1 by 3. That's going to give you a 3 by 3. Oh my. So we're going to get our b and our a, and it's going to give us, oh my, a 3 by 3. Okay? Yeah. Okay. This is row 1, column 1. Okay? Look, this one, row 1, column 1. Look, that's the entire row 1. Okay? This is the entire column 1. So it's just 4 times negative 2, negative 8. Now the second one, it's row 1, column 2, so it's 4 times 1. Okay? Row 1, column 3, 4 times 3. Row 1, okay, now it's row 2, column 1, negative 6 times negative 2. Row 2, column 2, negative 6 times 1. Row 2, column 3, negative 6 times 3. Row 3, column 1, 5 times negative 2. Next, it's 5 times what?
1.
And then
3.
5 times 3. So finally, we have negative 8, 4, 12. 12 minus 6 minus 18 minus 10, 5, 15. Here we have it. Okay? All right. So this stuff all hold. Associative property, like if you want to multiply a times b times c, you can do a times b then c, or a times b plus c times c. You can multiply a scalar any which way. No, because you're not messing the order. Like a, b, c is staying as a is first, b is second, c is third. Okay? It's when if you had done c times b times a, that it would have, you know. So you can distribute this way, or you can distribute that way. That all works. No. Because then you're commuting b times c, and that doesn't work. Okay, so we know about the identity matrix. Yes, we talked about this last time. You basically have a main diagonal of 1s. Yes. All right, now, suppose you have the number 5. What can you multiply 5 by in order to get 5 back? 1. If you have a matrix A, there is an analogous entity that if you multiply it by matrix A, you get the same thing back. Well, here if you multiply a number by 1 to get the same thing back, in the world of matrices, you multiply by the identity matrix to get the same thing back. Okay? So, multiply a matrix by I to get the same thing back. No, I as in capital I as in the identity matrix.
Why would you want to get the same thing back?
Well, it's like, you didn't ask me that question when I asked you the one about the 5. You know, like, sometimes you just have to. Okay. Well, so, you're never going to want to get the same thing back, but I'm just saying that, like, the identity matrix, it's the same thing as the number 1. Right? Like, for all intents and purposes, that's what it is. Okay, yeah. Huh? Yeah. 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 Okay, now, so here's where the one or the identity matrix really comes into play. Suppose now you have a number 3. What can you multiply this by to get a 1? By a third, right? So this is called the multiplicative inverse. It's the same as the reciprocal, but it's the multiplicative inverse. Now, suppose you have a matrix A. That's not negative, that's just A. What can you multiply that by in order to get a 1? Or in this case, in order to get the I matrix, right? That is the inverse matrix. Let me tell you in another way. Suppose you have 3x equals 5. How do you solve for x? You divide by 3, or you multiply by 1 over 3, right? In matrices, if you want to divide by a matrix, there is no such thing. You multiply by the inverse matrix. Okay? So, can't divide by a matrix. What you do instead is you multiply by inverse matrix. Okay? Now, we write the inverse matrix as A inverse like this. Okay? And the way it works is if you have A times A inverse, and if you have A inverse times A, both cases give you the identity matrix. All right? So to determine whether A and B are inverses, check if A times B equals I and B times A equals I. All right? So let's see here if A and B are inverses. Okay? All right. So first we're going to multiply A times B. What's the product matrix going to be as far as dimensions? Right. All right. So in the first position, we have row 1, column 1, right? So what do we get there? We get 5 times 5 plus 6 times negative 4. How much is that? That's a 1, right? Row 1, column 1. Okay. Now I'm going to do the one right over. That's row 1, column 2. And that's 5 times negative 6 plus 6 times 5. How much is that? 0. Now, the second row. Row 2, column 1. It's 4 times 5 plus 5 times negative 4, 0. Okay? Next one, I get row 2, column 2. 4 times negative 6 plus 5 times 5. What do we get? Positive 1. So look at that. I got the identity matrix back. Okay? Well, almost. Now we have to check B times A, because remember, they don't give you the same thing, right? So 5, negative 6, negative 4, 5. Yes. No. Oh, wait, do you have to write out this? Yeah, I would. Okay? But you don't have to write out this stuff. Okay, like the multiplication and stuff. All right, so, yeah. Okay, so row 1, column 1, 25 minus 20, no.
Oh, minus 24.
25 minus 24, right. So that's a 1. Row 1, column 2, 30 minus 30, 0. Believe it or not, you get a 0 here. Believe it or not, you get a 1 here. So yes, A and B are inverses. Woohoo! It's 5 times 5, 25, plus negative 24. Now, here, this is how we checked if the two were inverses. Well, what if now you're given a matrix and you have to find the inverse? It's a two-step process. Okay? So to find the inverse of a 2 by 2 matrix, it's different for a 3 by 3. This is a 2 by 2. All right? First, what you have to find is this thing called the determinant of A. And it's written either as det of A or A in bars. Yeah. We don't call it absolute value though. And the way it works is, the way you find it is, it's really easy. You multiply the numbers on that diagonal and you get AD. You multiply the numbers on the other diagonal and you get CB, and you subtract them. Always in that order. That's the determinant. Okay? Now, to find the inverse, okay, the main diagonal switches places, okay, and the other diagonal changes signs. It sounds so much more complicated than it is. Sign. You find the, I'm going to do one. Yeah, it doesn't. But it's like super simple. All right, so first here we're going to find the determinant. All right, and that's this. You take the first diagonal, okay, minus the second diagonal. So what does that give you? Okay, if the determinant is 0, no inverse.
Wait a second. Oh.
Okay? We say the matrix is singular. Like, oh my God, you're so singular. Okay? Like that. All right, let's find the determinant of A here. Main diagonal gives you negative 2 times 6 minus other diagonal, negative 4 times 4, negative 12 plus 16. So the determinant of A is how much? 4. Well, yeah. Okay, now here's what you do. To find the inverse, you take 1 over the determinant. Okay? 1 over that one. Why? Because that's what some math person said. Okay? Times this main diagonal switches places. So 6 comes up here, negative 2 goes down there. 6, negative 2. The other diagonal stays where they are. They just change sign. So 4 becomes negative 4. Negative 4 becomes positive 4. That's it. And then this is A inverse. You distribute. So A inverse is 6 over 4, negative 4 over 4. 4 over 4, negative 2 over 4. Do you simplify? Of course you do. 3 over 2, negative 1, 1, negative a half. That is A inverse. All right? Now, determinant of a 3 by 3. Oh my God, so much fun. Okay? So much fun. So this is one way. We don't do it that way.
Good.
Here's how we do it. You see the matrix here? You clone the first two columns right next to it. Why? That's just the rule. Yeah. Then, okay, you multiply along these arrows here. You just draw arrows and you multiply, or diagonals and you multiply. Yes. So A times E times I, blah, blah, blah. Now, the ones along this direction are added. So plus, plus, plus. The ones in the other direction are subtracted. Minus, minus, minus. And you have 3 and 3. So again, let's just do one. But it's so much fun. Okay? So first we're going to find the determinant. Here's how we're going to do that. That's not my name anymore.
What?
Math person.
Okay, so 3. Negative 2 and 1. Let me do this and I'll answer your question.
Mrs. Gauss Jordan.
I wish. All right. Okay. First diagonal. Come on, we got 3 minutes. Yes. So first diagonal, here. Here. I messed up. Hang on. Yeah, you just clone them. Yeah, only 2. And now you multiply here. You draw diagonals. You have to have 3 numbers on each diagonal. All right, now we're just going to multiply the ones on the first diagonal. 3 times minus 1 times 5. Doesn't matter. Plus 1 times 4 times 1. Plus 0 times negative 2 times 2. Now, I'm going to go in the opposite direction. Okay, I got 3 diagonals. 1, 2, 3. Each of these are going to be subtracted. Now, here's a little friendly advice. Write the minus sign first, then go to the matrix, because you're always going to get confused with the negatives. So here I got 1 times minus 1 times 0. Minus, go back, 2 times 4 times 3. Minus 5 times minus 2 times 1. All right, next. Now, Henry, what do we get here? Well, this is 0, this is 0. So we get negative 15 plus 4 minus, what is that, 24? Minus, no, plus 10. Okay? When you multiply all that, what do you get?
You mean when you add them?
Yeah, you mean it. Yes, that's what I mean. Is it negative 25? So this is the determinant of A. Okay? Now, so this is how you find determinant of a 3 by 3, and you can't deny the fact that it's fun. Now, to find the inverse, we're going to talk about this tomorrow. It's literally like a second and a half. You can, do we meet tomorrow? Yeah, early in the morning. So you can do all of this due tomorrow. The only thing I will allow you to not do is if you have to find the inverse of a 3 by 3. Not the determinant of a 3 by 3, you do that. You also do the inverse of a 2 by 2. It's only the inverse of a 3 by 3 that you're allowed to not do.